Hey everybody, Trey here. Welcome back to another video. Our highly advertised multi-day severe weather event, possible severe weather outbreak, is set to begin today, Monday, April 15th, across parts of the central and southern plains before shifting east Tuesday through at least Wednesday across parts of the Midwest and Mid-South. This is a very complex setup, a lot to talk about in this video, so let's go ahead and dive right into delineating the risk areas for you. This is the SPC outlook for today, hot off the press, just came in a few minutes ago. We have an enhanced risk level 3 out of 5 in the orange shaded region here, from far southern South Dakota through much of central and eastern Nebraska down into much of northern, central, and western Kansas. That includes places like Valentine, Nebraska, Lincoln, down toward Dodge City, in that vicinity in southwest Kansas, so anywhere in between in the orange shaded region here, under the gun for that greatest threat for severe weather today. We do have a large slight risk area, level 2 out of 5, extending from really the Rapid City area southward into much of Oklahoma, down into northwest and west Texas, places like Abilene, Wichita Falls, Oklahoma City Metro, Tulsa, Wichita, under the gun for that level 2 out of 5 risk as well. All hazards on the table for today, and they just actually updated the tornado probabilities. We before had a large 5% area across the threat area, but now we have a smaller area of 10% hatched here in the yellow stippled region from central Nebraska southward into southwest Kansas for the threat for tornadoes, perhaps a few strong, especially as we go into the evening hours tonight. Going to be a pretty potent setup today, and we have a large 5 and 2% areas surrounding that going down into northwest Texas. So a broad area of tornado potential today, but that greatest threat for a strong tornado or two does exist in that yellow stippled region. Large hail also going to be a significant threat today, especially up here from Kansas into Nebraska and southern South Dakota. In the 30% stippled area here, that is our greatest threat for very large hail, perhaps 2-3+ inches in diameter. Also a separate area of significant severe hail possible from West Texas into southwest Oklahoma, as you see here. And also damaging wind going to be a threat today. A couple of large 15% areas there across the enhanced risk, and then farther south across northwest Texas. So all hazards on the table for today. Pretty potent setup on the table for this Monday. Then we go into Tuesday. The threat shifts east, and the SPC has outlined an enhanced risk area across parts of southern Iowa, northeast Missouri, into western Illinois, with a large slight risk area surrounding that. All hazards once again on the table for tomorrow, including the threat for a few strong tornadoes in the yellow 10% hatched area there, just east of the Des Moines metro down toward Hannibal, just north of Jefferson City, Missouri. So decent area for strong tornado potential tomorrow. 5% areas down into western Arkansas as well. Large hail also going to be a threat in that enhanced risk area, as well as some damaging wind. Then we move into Wednesday. Threat is there for Wednesday. Just a 15% area, nothing hatched at this point. Significant severe weather not expected at this point. That could, of course, change. Not going to talk too much about Wednesday in this video, as we're going to need to see what happens Tuesday to really get a great picture of what's going to happen Wednesday. But for now, we have a slight risk extending from basically western Kentucky, northwest Tennessee, into Indiana, western Ohio. So that is expected to be the greatest threat area for Wednesday. So we're going to focus on today's threat for the most part in this video, and then we'll go into Tuesday before taking a brief look at Wednesday to close out the video. So without further ado, let's go ahead and get started. Let's first take a look at what's going on currently in the atmosphere. This is our SPC mesoanalysis page looking at the 500 millibar map, and we see our big old trough here across the western portion of the country. Somewhat of a compact trough compared to some other troughs we've seen this season, but overall a nice potent trough here, strong jet streak rounding the base of this trough. That should again eject into the central and southern plains as we go into the afternoon and evening today. Again, as we talked about in our video a couple days ago, the timing is going to be a little bit delayed with the ejection of this trough. It's going to hang back here a little bit and finally start ejecting into the central and southern plains by probably late this afternoon to early this evening. That means the forcing is going to hang back a little bit, and so convective initiation may be a little bit delayed, closer toward that late or early evening towards sunset time frame. And after that point, forcing will become a little bit stronger, and storms will be able to increase in coverage and intensity. But potent trough here, nice exit region moving into the Kansas-Oklahoma vicinity going into the afternoon hours today. And so we have a very strong synoptic scale forcing for ascent in this particular environment. We've started to see southwesterly flow traverse the higher terrain of the Rockies. As a result, we've seen a little bit of surface cyclogenesis take place over the past several hours. Broad surface cyclone at this point, but it is expected expected to tighten up here in the kind of northeast Colorado, western Nebraska vicinity today. We're going to see a very strong deepening of that surface cyclone, and that will really try to pull the moisture northward into parts of Nebraska, although questions remain over how far north moisture will be able to get. The farther we go into this event, the more we'll be able to get that moisture up into Nebraska. So that is why the SPC feels confident enough to add a strong tornado risk area up there into central and west central Nebraska. They do believe moisture is going to get there eventually. Through much of the day, however, we're going to see very limited moisture, and therefore we may only see a large hail threat and damaging wind threat develop with those storms, as the storms are expected to fire maybe a little bit earlier up here with a little bit extra forcing from this surface low compared to down here along the dry line. Speaking of moisture, let's take a look at our surface moisture here. So this is our current surface, raw surface observations, and the moisture has been a real potential fly in the ointment with this setup. Not so much at the surface, but the overall quality of the moisture. So first we'll take a look at the surface moisture. 60s dew points all the way up here to the Salina area, the I-70 corridor in north central Kansas. So we have a broad warm sector that has developed here ahead of a developing dry line that looks to be right across the Texas and Oklahoma panhandles at this point. So pretty ample surface moisture here, 60s dew points across a broad region going into much of Kansas, Oklahoma, Texas, Missouri, down into Arkansas at this point. So plenty of real estate for storms to work with today. And we're going to continue to see that moisture stream northward, and we'll have plenty of moisture ahead, at least at the surface, ahead of the dry line as it starts to tighten up going into this afternoon. All right, let's take a look at some observed soundings from this morning, taken just about an hour ago as I'm recording this video, just after 8 a.m. Central Daylight Time here in Norman. This is the Norman, Oklahoma 12Z sounding, and here is that issue we were talking about. You can see the surface dew point, 64 over 63 at the surface, but that moisture does not extend very far off the surface at all. Temperatures warm drastically and the dew points drop off drastically just above the surface, so very shallow moisture that we're dealing with this morning beneath a pretty stout capping inversion associated with the elevated mix layer of steep lapse rates aloft here. You can see right in that region surrounding the 700 millibar level. That is our elevated mix layer, or EML. We talk about it all the time on this channel. It's that layer of warm, dry, well-mixed air that originates from the higher terrain out west and gets transported on the southwesterly mid-level flow atop the moist layer here in the plains. So very stout elevated mix layer today, and that is going to preclude severe thunderstorm development for much of the day. Given the fact that our forcing is lagging a little bit back and timed a little bit later than it would otherwise normally be, we're not going to see a lot of cap erosion for much of the day. We will see some warming here, especially across parts of northwest Oklahoma into Kansas and Nebraska, where there's expected to be a little bit more sunshine, dealing with a little bit of cloud cover here, perhaps moving in ahead of the jet streak here this afternoon across parts of Oklahoma into Texas. So that may preclude heating a little bit farther to the south. But farther to the north, we are expecting to see some heating, and that will allow surface temperatures to rise. And with the surface low continuing to tighten here in northeast Colorado, western Nebraska, we'll see that low-level flows really start to strengthen and back out of the south or south-southeast, helping to pump continued moisture advection into the region. And therefore, we should be able to erode some of the cap during the day, but we're really going to need that forcing to fully erode that cap, and that probably won't take place until closer toward early evening and sunset. So that is going to delay convective initiation a little bit in this setup, probably towards 6-7 p.m. at the earliest, especially across parts of the dry line from across the Kansas portion of the risk area and farther south. So lots of dry air aloft as well to deal with, so early updrafts may struggle as well. We are expecting some moistening through the column throughout the day, but we are going to see that dry air stick around, especially in the mid and upper levels of the atmosphere, and that may allow early updrafts to struggle just a little bit. They might start ingesting a lot of that dry air, what we call dry air entrainment, and so they may struggle a little bit for the first hour or two of their life cycle, but eventually, once that stronger forcing comes in, once we get continued moisture advection going into the evening, and that low-level jet ramps up, we should be able to sustain discrete supercells in this environment. So not a perfect thermodynamic profile here this morning across the plains, but some signs are definitely there that we will see an improvement in this profile going into the afternoon, and that will favor storm development by early evening across the region. Let's take a look here up at Dodge City. I believe this is west of the best moisture. Yeah, you can see here we are kind of in that moisture plume, 59 over 57 at the surface, but once again, it is very, very shallow, very stout inversion here. Just above the surface, indicative of that elevated mix layer. So we are going to have to work that out. Dry air definitely in play today, but again, we should see at least some moistening through the column and some lifting and cooling of this capping inversion, especially as the trough starts to eject into the central and southern plains. Up to the north here, North Platte, we are well north of the best moisture. Not something you like to see on the morning of a severe weather event. 30s dew points up here across the region, but we do have 50s just to the south. So we probably will be able to get that moisture in, at least 40s and 50s dew points up here to the east of the surface low by this afternoon. We do have 60s dew points lurking there along the I-70 corridor near Salina, so do suspect that we will try to get those 60s dew points up here. May struggle again early on in the setup, but as we go longer and longer into the evening, we should get those dew points up there into central Nebraska to foster that robust severe threat up there. So that is what we're dealing with today as far as the observed data goes. So that is just one of the flies in the ointment that has been prevalent with this setup for the last several days, is the moisture depth and quality. Again, we're expecting to see some increase in that moisture depth and quality going into the afternoon and evening hours, which should foster a severe threat. Deep layer shear on the weak side, but again, the trough is still hanging back here at this point. Our 500 millibar trough and the stronger flow associated with that trough all the way back here in the Texas Panhandle toward Colorado, New Mexico, and westward. So once we see that flow start to impinge upon the region, that's when we'll start to see deep layer shear strengthen. Only about 27 knots or so here at Norman this morning, but again, that is going to strengthen pretty drastically as we go into the day. And we'll start to see that low-level jet ramp up as we go into the day as well. Again, that surface low is expected to tighten. Low-level cyclone expected to really deepen as well. Here's our 850 millibar flow at the moment. Just a broad cyclone at the moment, 40 to 50 knots here, situated from Kansas northward into the Dakotas. But again, once we get that low to strengthen, we'll see a broad low-level jet plume extending down here into the central and southern plains to really foster a strong low-level shear environment, especially going into the early evening hours toward and after sunset to support that strong tornado threat. So let's take a look at some model data now. This is the 6Z NAM. I'm recording this a little bit earlier than usual, so we have to use our 6Z run of the NAM, but it should give us a good idea nonetheless. So here's our trough as initialized on the 6Z NAM, going to eject into the plains as we go into the afternoon and evening today. You can see here why the timing is a little bit delayed. Here we are at 21Z, forcing the stronger flow aloft is just starting to impinge upon this region. So we probably won't see development until at the very earliest after 21Z, most likely going to hold off a little bit longer, as that cap will probably be a little bit stubborn going into the late afternoon hours. But then we finally start to see that jet streak make its way into Kansas and Oklahoma. A little bit stronger deep layer shear with southern extent, where that stronger 500 millibar flow is up to the north. A little bit more of a weaker flow regime, a little bit more meridional as well. So storms will be moving due north. One of the other aspects that may be a fly in the ointment with the northern portion of the setup is that early on the storms will be moving due north away from that returning moisture. So that could be an issue with those storms and their residence time in the best environment across Nebraska. But down here to the south, this is a pretty textbook looking trough impinging upon the region by about 0Z, which is 7 p.m. Central Daylight Time. So plenty of forcing for severe storms, stronger flow aloft situated down here across Texas, Oklahoma, southwest Kansas. So we should have forcing starting to move into the region by about 0Z, 7 p.m. Central Daylight Time. So if we were to draw out our jet streak here, pretty classic kinematics here, and split up that jet streak into quadrants, we are definitely right within that left exit region here, southwest Kansas into northwest Oklahoma, the Texas Panhandle. So that is your classic location for severe weather in these troughs. Of course, we can still have severe weather here in the right exit region, and we are expecting to see severe storms in that right exit region, but that left exit region is your classic location for significant severe weather, and that is going to be situated right over that western Kansas to southwest Oklahoma, northwest Texas corridor. So very favorable, very textbook look to this trough ejection, a little bit on the later side, but still pretty textbook as far as the geometry goes, and that will continue into the overnight hours Tuesday, early Tuesday morning, and we'll see the forcing strengthen as well going into the overnight hours, and that will probably lead to a blossoming of convective coverage and a degradation of the discrete mode into more of a clustered or linear mode. Let's go down to the surface, show you what's going to happen at the surface here. So we go into we start here into the morning, very broad surface low across Wyoming, Colorado. Again, that is expected to really tighten up as we go into the afternoon. This is 18Z, 1 p.m. Surface low really starting to tighten. You see some more closed contours there around that center of circulation in northeast Colorado. that surface low will meander off to the northeast, situated somewhere in the far western Nebraska panhandle region going into the evening today, and we'll have that tongue of moisture starting to feed up into that surface low to foster the severe threat up there. Down to the south, you can see winds strengthen and back very nicely going into the afternoon as that low-level flow strengthens. That will allow for that stronger low-level shear to develop and a very tight dry line to develop going into the afternoon. Let's take a look first at our southern plains sector here, and I will move to our dew point. You can see those 60s dew points all the way well up into Kansas, and even a little bit better than what the NAM is showing here. 60s dew points up to the I-70 corridor here, so a little bit better moisture return than what the 60 NAM was showing. But overall, a broad warm sector, low to mid 60s dew points across a broad region here from Kansas into Oklahoma at this point, and that is expected to continue to advect off to the north, and we will see a very tight dry line by this afternoon. Should have some strong convergence along the dry line here from Texas into Oklahoma and southwest Kansas by early this evening. Plenty of moisture here out ahead of the dry line to support severe storms. Now, one of the issues as well is a lot of the models previously to this morning have had a difficult time resolving convective development here out across southwest Kansas, much of western Kansas ahead of the dry line, especially down here into Oklahoma and northwest Texas along the dry line. And I've been, just haven't posted much about it here previously, but I've been thinking that is I'm very, very skeptical of that, and I'll show you a couple of the reasons why here. So let's take a sounding here at 0Z behind the dry line here. We'll do one in far southwest Kansas, and then we'll take one just out ahead of the dry line, that little dry line bulge there, by the way, that has been very prevalent in the NAM solutions here for the last couple of days. A little bit of a dry line bulge there. We've talked about dry line bulges before, how they can have a little bit extra convergence along them and a little bit stronger low-level shear along them to support more robust severe weather development. So let's take our look at our sounding from behind the dry line. You can see here very deep mixed layer behind the dry line. That inverted V profile extends up to about 600 millibars or so. That is a very deep layer of mixing that has occurred here behind the dry line. And as we've talked about before, the way we can see if the dry line is more likely to initiate is if that level of free convection ahead of the dry line, where the level at which the parcels become buoyant on their own, is within this layer of deep mixing behind the dry line. So here we are sounding just ahead of the dry line at 0Z in southwest Kansas. So our level of free convection is fairly low in this particular sounding, goes up to there. So our dry line circulation is, very, very deep at this point, and our level of free convection is well within that deep mix layer from behind the dry line. That is very favorable for storm development along the dry line. It makes it a much more favorable scenario for the dry line to initiate. Another reason is the lack of capping here by 0Z on a lot of the models. The NAM especially is showing a fairly good lack in a capping inversion here by 0Z. You notice here, ahead of the dry line, the moisture has deepened quite a bit up to above 850 millibars, and we're seeing very limited capping here. Our profile is pretty much fully destabilized at this point, at least on the 6Z NAM here. Previous runs were showing a lot of capping still remaining, which lent some concern in the fact that storms may not initiate. But here, an uncapped sounding with a very deep mixing behind the dry line, strong convergence along the dry line as well. I'll show you those winds along the dry line, south-southwesterly flow to the west of the dry line here with south-southeasterly flow ahead of it. So decent convergence along the dry line, especially down here in the Oklahoma and Texas Panhandle, southwest Kansas vicinity. So plenty of convergence along the dry line, deep mixing behind the dry line, and a lack of capping. Very, very skeptical. You're telling me that this profile here is not going to convect, especially with stronger forcing coming in. I just don't buy it, and I haven't bought it for the last couple of days, and the NAM is starting to come in line with that thinking, whereas previously it had quite a bit of capping remaining. Now we're seeing a fully uncapped environment right here by early evening, and with these kind of wind profiles, that is pretty favorable for a supercell development with that all hazards, possibly significant all hazards threat. So I do think we are going to see storm development along the dry line. Another reason why we might see storm development along the dry line is that the NAM is depicting a little bit of a shortwave moving through that is going to be well timed with this setup. So you can see here as we go looking at our 700 millibar flow, see a little bit stronger flow here starting to impinge upon the region by 21Z. A little bit of a kink in the overall height contours here as well. kind of coincident with the dryline. So this could be somewhat of the dryline circulation, but it is kind of tilted here if you look at it. The axis here, a little bit more of a negative tilt axis to the shortwave. Moving through pretty well timed here. This is at 4 p.m., so right out ahead of this from the eastern Texas panhandle down into West Texas and into southwest Kansas. This is at 4 p.m. Pretty well timed little shortwave here. Especially up here into western Kansas, you see kind of the kink in the height contours there. So right out ahead of that would be a favorite area for storm initiation. See a little bit of that down here as well into northwest Texas. So that could be a little bit of an aid as well in the prospects for storm initiation southward along the dry line in these areas. So with all of that said, I just don't buy that we're not going to see any storms along the dry line here, especially in that southwest Kansas corridor where we see this kind of profile ahead of the dry line. Lots coming together, especially on the NAM here. As I said, 77 degrees surface temperature. That is a little bit better than what it was showing. A couple of runs ago, it was showing, like a 72, 73 degrees surface temperature at 0Z, which is just way too cool. And that was allowing a little bit more cap to hang around. I just don't buy that we're not going to see development along the dry line with all those factors at play. So let's go back here. Let's take a look at the 850 millibar map real quick. Take a look at the low-level jet, how it responds through the day. So low-level jet plume displaced off to the north at this point, but that will change as we go into the day. Broad area of low-level jet extending down into the southern plains from northwest Texas northward ahead of the deepening low-level cyclone. So plenty of low-level shear for supercells. Up here to the north across Nebraska, a little bit more backed flow at 850 millibars. And with the surface flow expected to be backed as well, that may lead to a little bit of a decrease in low-level shear up there, whereas farther to the south across Kansas, I'll zoom in here for you, the 850 millibar winds are a little bit more veered, and that's not, I'm not saying more southwesterly, they're just out of the south here, almost due south here across the western Kansas corridor, and with backed surface winds out here out of the south-southeast, that could allow for a little bit more low-level shear down here in kind of a sweet spot between a lack of low-level jet to the south across West Texas and a little bit more unidirectional flow in the low levels across parts of Nebraska. So I think that sweet spot today is going to be right in that southwest Kansas to central Kansas corridor where these parameters are coming together. Back to our moisture here real quick. So up to the north, the NAM tries to get those 60s dew points northward by 0Z. As I said, the farther we go into the setup, the better that moisture is going to be farther to the north. And so we are expecting to get those 60s dew points up there eventually. But this corridor is a little bit skinny, especially with northern extent, but enough room for storms to work with going into the early evening hours to provide that severe weather threat up there with low to mid-50s dew points ahead of the dry line and surface low in western Nebraska. Let's take a couple soundings here as well. Take one here at 0Z. Again, storm initiation might be a little bit earlier up here, given the a little bit extra forcing from the surface low. So we'll take a sounding up here. We'll take one. We'll once again analyze our sounding from down there in southwest Kansas, and then we'll take one down here into western Oklahoma. Just kind of getting a view, a nice wide view across the region down here, tight dry line into West Texas. So we'll take a few soundings from here and look at the soundings across the region. So here we are at in western Nebraska ahead of that surface low. A little bit more well-mixed boundary layer, a little bit more of an inverted V profile here, 77 over 56 at the surface. A little bit higher temperature dew point spreads. Again, up here in the high plains, it doesn't matter all that much. You can have a little bit higher temperature dew point spreads, higher than our kind of 20-degree threshold, and still get tornadoes, but it is going to be a little bit more difficult up here with a little bit more limited low-level moisture to begin with. So 77 over 56 at the surface, deeply mixed boundary layer, but fairly unstable boundary layer. 3,000 joules per kilogram mixed layer CAPE, so plenty of instability to deal with. Steep lapse rates aloft, indicative of robust updrafts. Again, deep layer shear a little bit on the weak side, only 25 knots of effective bulk shear up here. We are a little bit farther removed from the actual trough net, stronger forcing, stronger flow aloft associated with the trough. So deep layer shear may be on the weaker side up here, at least to begin with. And so that may lead to more of a multi-cell mode up here. Weaker low-level shear, as I said, as well, given a little bit more unidirectional profile in the lowest kilometer or so of the atmosphere. So we do have some turning there in the lowest 2 to 3 kilometers, but in the lowest kilometer or so, which is what we want to look for tornadic activity, not all that favorable for tornadoes, given a fairly unidirectional wind profile in the lowest kilometer or so. But still favorable profile for large hail damaging winds and maybe a tornado or two up there. And again, this is valid at 7 p.m. Central Daylight Time up in western Nebraska. Down in southwest Kansas, once again, here is our sounding there from just east. I'll remind you here, just east of the dry line there in southwest Kansas. So really right around the Dodge City area this evening. And this is a really textbook sounding for all severe hazards, including the threat for significant tornadoes. 77 over 66 at the surface, so better moisture down here to the south. And we've seen the moisture quality deepen just a little bit going into the early evening hours. A little bit of dry air aloft, as we said, but once again, it is, I think we will, with all the other ingredients at play, that shouldn't be too much of an issue, although storms may struggle a little bit in their first hour or so of their life cycle. But very unstable profile, 3,400 joules per kilogram mixed layer cape, plenty of instability to deal with. That should foster, at least initially, a large hail threat. Strong deep layer shear, 40 plus knots of effective bulk shear long hodographs, and nicely curved, clockwise curved hodographs here in the low levels, almost 300 meters square per second squared effective storm relative helicity as that low-level jet starts to ramp up going into the early evening hours. So all in all, I mean, look at these analogs. We don't look at the analogs all that much, but severe hail analogs out the wazoo here, as well as some tornado analogs with quite a few potent ones there showing up. So again, I think this is going to be your sweet spot there in southwest and west Kansas, going into central Kansas in the early evening hours toward and after sunset, which is where the best overlap of ingredients is expected to be. Western Oklahoma, a little bit stronger capping down here with southern extent. But still, I think we're close enough to where it might not be too much of an issue. Similar profile to what we saw up to the north across parts of southwest Kansas, with strongly unstable environment, strong deep layer shear for supercells with low-level shear favorable for tornadoes. So if any storms can fire across Oklahoma, and that is a question, given the timing of this shortwave, I'll go back to 700 millibars here. So our shortwave, it's going to just depend on we're going to have to watch this 700 millibar flow. NAM does have a little bit of a shortwave here moving in right around 7 p.m., so that could be just enough to get storms to go. But SPC believes that we might see a relative minimum in convection across Oklahoma and the eastern Texas panhandle until that Pacific front comes in the overnight hours. But we'll have to watch that for sure. If any storms can fire here across this region, they certainly would be supercellular in this profile. Down to the south in West Texas, a little bit stronger capping here, so probably not as robust of a severe threat down here, but we are expecting a couple storms to fire along the dry line in West Texas. Limited low-level shear, so not, perhaps enough for a tornado or two down there, but again, the greatest threat is going to be up to the north in that Kansas to Nebraska corridor. Then we go into, let's say, 3Z here. I'll go back to our dew point map. 3Z, and we really see that dry line start to retreat a little bit and tighten eventually. And this is when low-level shear is expected to really ramp up. So let's go ahead and take a sounding here out ahead of the dry line. I'm showing a little bit of a weird plume there of sub-60s dew points. I'm not sure that's going to be legitimate, so we'll have to watch that for sure. Northwest Texas here, and then we'll take one up here into Nebraska, where a little bit better moisture. I'll take one there in north-central Nebraska. So this is our northern sector here up on the surface low, and you can see what happens with the low-level jet. Low-level jet ramps up significantly after dark. I'll show you the 850 millibars here. Significant ramp up in the low-level jet after dark across the entirety of the region. Very strong flow, 60 to almost 70 knots here across parts of the region from Nebraska, South Dakota, southward into Kansas and Oklahoma. So that low-level shear is going to ramp up big time. Strong instability, 3,500 joules per kilogram mixed layer cape up there in Nebraska. A little bit better moisture has worked its way into the region, and very strong low-level shear to support tornadic supercells up there. Again, effective bulk shear on the low side, but we could have some terrain influences to make that a little bit of a moot point here today. So strong low-level shear, strong instability would be favorable for tornadoes up there, perhaps strong tornadoes. Down here to the south, let's take one in Kansas. I believe this is in Kansas. Let me check just real quick. So this is northwest Texas, actually. And so you can see that low-level jet extends down there. And again, this is what we talked about a couple days ago. The fine line is going to be if we can get mature surface-based supercells to sustain themselves into the evening when that low-level jet ramps up, because the low-level instability is going to weaken, a little bit more capping working its way in as the surface temperatures cool after sunset. But as we've talked about in many cases before, including, for example, the Greensburg, Kansas case from 2007, if you have strengthening low-level shear with time, that can help overcome this little bit of capping that works its way in and can sustain significant tornadic supercells well into the evening, even though the low-level stability works its way back in. But very strong low-level shear here, favorable for all severe hazards, including strong tornadoes if that can maintain itself. Up here into Kansas, same thing. Again, I think this is just a little bit wonky as far as the NAM goes, dropping those dew points into the 50s. I don't think that's all that favorable, but certainly a favorable profile for significant tornadoes here if surface-based supercells can maintain themselves. So all in all, a very potent setup here, especially going into the overnight hours. Just a quick note about storm mode this evening. I'll draw in our dry line here, which is in pink, and then we'll overlay our deep layer shear vectors on that dry line to see how they are looking as far as the angle between those shear vectors and the dry line. And you can see a great degree of perpendicularity between those shear vectors and the dry line. So that should foster a long window for discrete supercells in this environment, along with the fact that capping is expected to hold on maybe a little bit longer than anticipated. Some of that drier air may work to keep storms discrete as well. So all signs are pointing to a very discrete supercell mode with this environment until the Pacific front eventually overtakes the dry line, at which point forcing will increase and storm coverage will likely increase in tandem. Let's take a look at a couple of cams here. I don't believe our other cams are coming in quite yet, but we can look at our most recent HRRR run to give us an idea of what the radar might look like later on today. So here we go into the afternoon. You see some of that showery activity across southwest Oklahoma, northwest Texas, which may somewhat stunt heating a little bit across this region, but we should still see enough to allow for some initiation along the dry line there. So this particular model run, and this is just a cam, and the cams don't really do all that well with these setups, but we can see here stuff along the dry line here by 2122Z, interestingly enough. Up here across Kansas, not a lot of convective attempts here until much later in the event. You can see those supercells up in Nebraska, South Dakota by about 6 to 7 p.m., and some attempts along the dry line here from northwest Oklahoma into western Kansas. Now, earlier runs of the HRRR did have a little bit more potent look there for the southwest Kansas corridor. This is the 10Z HRRR, and you can see a lot more robust activity there in southwest Kansas, which I think is a much more plausible scenario. And again, this is just a cam. It's going to waffle back and forth. They, again, don't do very well with these setups, but you can see here how different that is from what we just showed you. Lots of activity up here in Nebraska and much more activity along the dry line with no activity down here into northwest Texas. So it's very easy to see how much these models flip-flop. And so take these with a grain of salt. But overall, I think the meteorology does show us that that southwest Kansas corridor is going to be a favored corridor for storm development, perhaps very isolated storm development going into the early evening hours. Again, I just don't buy that we're not going to see any robust attempts along the dry line going into the evening. Again, the more guaranteed target up here in Nebraska, southern South Dakota, and perhaps here along the dry line into northwest Texas. But I think that sweet spot, northwest Oklahoma, northward into western Kansas, going to be able to support a storm or two this early evening into the overnight hours. A lot of last night's cam runs were also starting to show convective activity there in southwest Kansas, which had not been the case prior to yesterday evening's runs. Here's the WRF ARW. Initially, you see storms fire there in Nebraska to South Dakota, another batch of activity there in the northwest Texas corridor, and then right after dark, we start to see initiation there in the kind of Oklahoma Panhandle region moving into southwest Kansas, and we get a pretty intense-looking supercell there. Don't look too much into the timing. Again, that will change. I think by 6 to 7 p.m. we'll start to see updrafts going up, but nonetheless, the model here showed a robust supercell developing in southwest Kansas last night. NSSL WRF model. Here from last night. This is at 0Z from yesterday evening. Once again, these models starting to show convective development there in southwest Kansas, whereas previously they had not. So NSSL WRF showing the same thing, activity in Nebraska and South Dakota, and then initiation there in southwest Kansas that became more robust going into the nighttime hours. So that was not the case prior to that. A lot of the models had no development at all in southwest Kansas, but now last night's batch had quite a bit of activity, and we're continuing that into some of these morning runs as well. All right, let's take a look now at Tuesday's threat. What happens on Monday is going to modulate what happens on Tuesday, just like what happens on Tuesday is going to modulate what happens on Wednesday. So we'll start this evening at 500 millibars on the 6Z NAM. That trough continues to eject off to the east and really start to take on a negative tilt as we go into tomorrow morning. Forcing already well up here into the target area for tomorrow up there in Iowa, Missouri. So we should probably get an early start to convective initiation tomorrow. And that threat will extend all the way down to the south with more of a glancing blow down here across the Arkansas toward the Arklatex area. So that could be a separate area of convective development that we'll have to watch. A little bit more glancing blow from the forcing, a little bit less forcing up down here, which could make for a more discrete supercell mode. But we'll get to that here in just a second. Trough continues to eject off to the northeast going into the evening hours tomorrow. And then we should see that severe threat continue into Wednesday. But overall, the upper pattern is going to change a little bit going into Wednesday. But for Tuesday, very potent look here as the trough takes on a nice, pretty classic negative tilt nature, and that forcing overspreads the Midwest into the Mid-South. Down at the surface, let's go back to this evening, and we'll see how that surface low starts to progress going into tonight and tomorrow. So that surface low by this evening going to be situated somewhere here in the western Nebraska corridor. Very tight surface low, strong pressure gradient winds out ahead of that surface low will continue into the overnight hours. Surface low shifts off to the east going into tomorrow, probably tightens a little bit, kind of constricts a little bit as we get that negative tilt nature to the trough to take place, a little bit stronger low-level response. And we'll have that low somewhere in the eastern Nebraska corridor by tomorrow early afternoon. This is at 1 p.m. Central Daylight Time tomorrow. Low is situated there just west of the Omaha-Lincoln area there in Nebraska. So we'll probably have a cold front extending down to the south. A Pacific front will overtake the dry line late tonight, and that will allow that to shift off to the east. Another reason why we'll probably see a proliferation of convective development along that Pacific front as it overtakes the dry line and forcing increases along that boundary. So by tomorrow, early afternoon, low in eastern Nebraska. Moisture not going to be an issue with tomorrow's setup as well. I'll zoom in here to our Midwest sector and pull up our dew points here. I'll go to our Central Plains sector so you can see how that moisture progresses a little bit better off to the east. So once again, our dew point, those 60s dew points, try to make their way up into Nebraska by this evening. Plenty of moisture down to the south. That will continue to advect northward ahead of the eastward moving surface low, and this will be what we're dealing with by tomorrow. NAM has a surface low here in eastern Nebraska. Warm front draped off to the east. Dry line / Pacific front down here to the south. Both of these will be favored boundaries to focus convective initiation tomorrow, especially along the warm front up here into parts of Iowa. And again, this is just one model, so keep the placement in mind. The NAM does tend to be a little bit farther west than some of the other models, but overall, the idea is going to be the same. Over across Iowa into down into Illinois. That is where our warm front is expected to be situated, and that will move off to the east going into the afternoon. Plenty of moisture pooled along that warm front to support a severe threat. And so let's take a couple soundings here out ahead, right along the warm front there in kind of the just west of the Des Moines area. And again, the SPC has the placement of the day 2 risk a little bit farther off to the east, perhaps. Southeast Iowa, northeast Missouri, western Illinois, but that could change over the coming days. Could be a little bit farther west. It just remains to be seen. Here we are at 21Z across parts of southern Iowa. Very interesting profile here. Deep layer shear, not all that strong. You can see the photograph is very, very minimal compared to a typical significant severe weather setup up here. We have a little bit of low-level shear to deal with. Not much, 100 meters squared per second squared effective storm relative velocity, but we do have pretty ridiculous low-level instability and deep layer instability as well. 2,500 joules per kilogram mixed layer cape, 0 to 3 kilometer cape at 360. That is probably the highest I've ever seen on a model run. Probably going to be not going to be that much, but overall the idea is that we're going to have very strong low-level instability to support the stretching of any vorticity and low-level spin along these boundaries into the vertical ahead of the surface low, which could foster a tornado threat. Strong tornado threat, I'm a little bit skeptical. I don't really know if a strong tornado threat will materialize with this kind of a profile, wonky mid and upper level winds, very limited low-level shear. Low-level shear certainly on the weak side, only about 30 knots or so. Which in these kind of surface low setups, not always a detriment. Let's take one farther east along the warm front to see if we have a little bit better shear out here. I suspect the low-level jet's probably off to the east a little bit, and that's exactly what the case is. Low-level jet plume is off to the east here a little bit. Farther to the southwest, a little bit less deep layer shear, given a little bit weaker flow going into the mid and upper levels of the atmosphere. Here's 500 millibars And you can see that flow is displaced off here to the east. So this is a much more interesting looking profile for significant tornadic supercells. Strong low-level shear, very strong low-level jet, upwards of 50-55 knots here at 21Z, 4 p.m. Central Daylight Time. Decent instability, 1,300 joules per kilogram mixed layer CAPE, 68/65 at the surface. We'll have to watch for antecedent convection in the morning. That could hamper destabilization just a little bit if we have a little bit more clouds and showers and some embedded storms sticking around later. But if those can get out of the way, it shouldn't be too much of an issue destabilizing the atmosphere. And we'll have some steeper lapse rates working in with a little bit colder air aloft from the center of the upper level trough. And working its way in. But strong low-level shear to certainly support a significant tornado threat, about 350 meters squared per second squared effective storm relative helicity. So all in all, this would favor that significant tornado threat if we can get a more supercell mode. One potential issue I see with the southern Iowa target, especially confined closer to the warm front, is that if we are focusing convection along the warm frontal zone, we may have a tendency for storms to cross the boundary a little bit quickly, given a little bit more meridional mid and upper level flow in this part of the region. So once this loads here, I'll show you. So I've drawn in our warm front in pink there. Notice our shear vectors are very much perpendicular to that boundary. Now in this case, that's not always a great thing, as storms will be moving probably due north or very close to due north, maybe north-northeast. And that is quite a motion that would allow for storms to cross the boundary pretty quickly. Now if the boundary lifts with the storms, which it very well could here, then it wouldn't be too much of an issue. But storms may have a tendency to cross the boundary a little bit quickly, which may allow them to be undercut quickly. So we'll have to perhaps look a little bit farther south along the Pacific front and in the actual warm sector south of the warm front for a little bit better residence time in the warm sector to allow storms to fully reach their potential. Shear vectors down here are a little bit more perpendicular to that initiating boundary, the Pacific front, so that may help things out a little bit as far as a somewhat semi-discrete mode there in an arc out ahead of the surface low and along that Pacific front. But if any storms fire near the warm front, they may tend to cross the front pretty quickly. But we'll see if the warm sector actually lifts with the storms as they fire, as that would be helpful in keeping them surface-based. But that is one potential issue with the setup up there in Iowa. But we'll have to just wait and see how that plays out. Farther to the south, probably another area of severe weather will develop. As I said, a little bit more of a glancing blow from the trough down here. Here's our main jet streak centered up there into Iowa, Illinois, Missouri. Left exit region up there, very favorable for severe weather. Down here, right entrance region of the jet streak, also a favorable quadrant for upward motion and severe weather development. So that would be across eastern Oklahoma, Arkansas into southern Missouri. Could be another area of potential severe weather development down in that region. As you remember, the 5% area does extend down into western Arkansas, so that could be another area of potential development of severe weather down there with a little bit better, a little bit less forcing for ascent, possibly with southern extent. Now, one of the interesting things with the setup tomorrow is that the Pacific front, that dryline Pacific front composite boundary, is expected to stall as we go into tomorrow afternoon. So here we are, evening hours tonight. That boundary, the Pacific front, will eventually overtake the dryline, shift it off to the east quite a bit. But notice what happens to the front. It stalls out a little bit. And so we even retreats a little bit here, especially across southern portions of the risk area. Up here to the north, it continues to move off a little bit. We do see those dew points lifting north with the surface lows ejection off to the north. So a little bit more movement in the front with northern extent, but down here to the south, that front stalls out pretty nicely going into the afternoon. So that could be a potential focus for severe weather, and not one of these cold fronts that just surges, allows for a lot of storms to develop. With a little bit weaker forcing down here in a stalled boundary, that could allow for a bit better development of semi-discrete supercells down here in eastern Oklahoma, the Arklatex up into western and northwest Arkansas. So we'll see here and take a look at our shear vector orientation with respect to the boundary. This is kind of a slanted boundary, not always all that optimal for semi-discrete supercells, kind of a southwest to northeast oriented boundary. We do have our shear vectors that are fairly perpendicular to that boundary, which could foster a few semi-discrete supercells down here in the late afternoon hours tomorrow as that front starts to stall out. Let's take a sounding here. A couple soundings out ahead of this boundary down across the southern portions of the risk area. Let's take one here and again, this could be shifted a little bit farther west than what is actually going to happen. The 5% area is a little bit farther out to the east than the actual boundary. So just keep that in mind. here with this particular model run. But we'll take a sounding here, eastern Oklahoma, in the better moisture plume there, and then one down kind of in the Arklatex region where we have our best moisture situated, as the severe threat could extend down that far as well. This is a favorable profile for severe weather. Instability a little bit on the skinny side, lots of dry air still hanging around in this part of the region, so that could hamper updrafts a little bit. But assuming we do get a favorable destabilization, again, I think 73 degrees is going to be a little bit on the low side as far as surface temperatures go. Classic NAM bias. Assuming we can get robust destabilization, we should have plenty of low-level and deep layer shear for supercells. Strong, long hodographs, effective bulk shear above 60 knots with low-level curvature there in the hodograph, pretty significant. Strong veering and strengthening of the low-level winds with height. About 250 meters squared per second squared effective storm relative helicity would favor an all-hazards threat there along southern portions of the risk area. Down into the Arklatex, same thing, but dry air might be a little bit of a bugaboo in the setup, helping to hamper updrafts in the early portion of their life cycle, but should probably see a few storms develop on the Pacific front here as it stalls out across the Ozarks down into the Arklatex. Then we go into Wednesday, real quick on Wednesday here. Again, what happens on Tuesday going to really modulate what happens on Wednesday. So we don't really know the specifics with Wednesday yet, but we do see that the trough continues to eject off to the northeast, and we're left with just broad westerly flow here across the region that is weakening with time. So deep layer shear should probably be weakening with time across this region. It might very well be a continuation of convection from Tuesday into Wednesday. That'll be our main severe threat. So we'll have to keep that in mind for sure. Definitely still a little bit of a wave here as this new wave starts to take over back to the west. Our surface low is moving off to the northeast with time up into the Great Lakes region. And kind of more displaced from our area of interest. Our warm sector kind of out like this. Favorite areas right in here. Just all in all, not a super favorable setup for significant severe weather up in this region. We should probably still have pretty strong moisture up into this region, probably 60s dew points continuing to advect their way off to the east as the surface low ejects off to the northeast. So we do have enough moisture to maintain a severe threat across this region going into Wednesday. I'll zoom in here and take a quick couple of soundings from across the region. So we'll take one here, southern Indiana, just to kind of see what is going on there on Wednesday. Again, what happens Tuesday, how much convection is left over from Tuesday, going to really modulate what happens on Wednesday. Overall, favorable looking profile here for supercells and severe weather. Veered low-level flow, but it does kind of curve counterclockwise as you go up into the atmosphere. Nice counterclockwise curvature in the hodographs. But as we said, deep layer shear on the lower side still adequate for supercells, 40 knots or so. But it is weakening with time, given the weakening mid and upper level flow with time as well. But overall, veering winds with height should favor a threat for severe storms with decent instability here. 1,700 joules per kilogram mixed layer CAPE. Plenty of instability for storms up in that region. That kind of Indiana, Ohio, Kentucky, Tennessee region on Wednesday. So a lot to talk about in this video. Very complex setup going into the next several days here, beginning with our threat today. Again, an enhanced risk from the SPC level 3 out of 5 from southern South Dakota into Nebraska and Kansas, with a large slight risk extending all the way down into the West Texas area. All hazards on the table for today, including that threat for strong tornadoes from central Nebraska southward into southwest Kansas, especially going into the early evening hours as that low-level jet starts to really ramp up. And assuming we have discrete supercells, which I think is a good possibility, that is going to be a favored corridor for maybe a strong tornado or two. And a tornado threat does extend down into western Oklahoma and central Oklahoma as well as down into West Texas for the continuation of storms into the overnight hours as that Pacific front catches up to the dry line. So again, I think storms fire initially up here in these corridors, southern South Dakota, northern Nebraska, with that hail and damaging wind threat. And then as better moisture works its way in, we could see a few storms start to develop a tornado threat up there in Nebraska going into the early evening hours. Storms probably fire down here along the dry line as well, although we'll have to watch how that early day showery activity and cloud cover impacts heating along the dry line. That could delay stuff down here as well. I think we'll see storms start to fire here probably around 6 to 7 p.m. Updrafts will start to go up around 6 to 7 p.m. here in southwest Kansas, northwest Oklahoma, and perhaps farther south along the dry line. And then they'll really start to get good right about sunset and after as that low-level jet starts to crank. So that's the overall timeline for today. Again, that tornado threat is there. Large hail going to be a concern as well, particularly in the 30% hatched area here. Threat for some 2-3+ inch hailstones. Very robust updrafts expected today, as well as down here in the West Texas to Southwest Oklahoma corridor this evening. Damaging winds also a threat today as well. Then we go into tomorrow, once again, enhanced risk across Iowa into Missouri and Illinois. We could see some shifting. We probably will see some shifting of the lines, perhaps a little bit farther west if that NAM solution comes to fruition. But overall, the idea is that we'll see significant severe weather ahead of the surface low, south of the warm front, ahead of the Pacific front, there in this enhanced risk area, level 3 out of 5, including Des Moines, Hannibal, down toward the Jefferson City area, under the gun for that enhanced risk tomorrow. Large slight risk extending south from there, eastern Oklahoma into Arkansas, southern Missouri. Could be a separate area of some semi-discrete supercells down there with a tornado threat, which will be maximized up in the Iowa, Missouri, Illinois corridor, 5% extending down to the south into Arkansas, and large hail going to be a threat as well, particularly in the enhanced risk area up there in Iowa and Missouri, and the threat for damaging winds is there as well. Then Wednesday, the threat continues into the east. Again, what happens Tuesday is really going to modulate what happens on Wednesday. So we're not really sure on the specifics for Wednesday yet, but that slight risk area here, level 2 out of 5, from Indiana, Ohio, southwestward into Kentucky, northwest Tennessee, is that favored corridor at this point for severe storms on Wednesday. So that's going to do it for this video. Multi-day severe weather outbreak is looking likely at this point, and we could see some significant severe hazards, including strong tornadoes and very large hail from this setup. So folks in these risk areas, keep those weather radios handy, keep your source of weather information handy, your local news stations, the National Weather Service in your area for the latest up-to-date information. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.